So hello everyone, and I hope everyone is doing well. What I want to discuss in the time value of money chapter of your book, which is I guess section 4.9 here, is the concept of internal rate of return, and just rather simply, the internal rate of return is the rate that sets the net present value of the cash flows equal to zero. Okay, so at some point, we're going to learn about the net present value, but this is the point that sets the net present value of the cash flows equal to zero. And this is a determinant in whether or not we're going to make an investment. Okay, so let's click here. The interest rate that sets the net present value of the cash flows equal to zero. So you know the present value and you know the cash flows, but you don't know the interest rate that equates them, okay? And that's what this is. So let's look at this timeline here. So you have an investment opportunity to invest $1,000 on the timeline, and you'll notice it's negative, right? Because that money comes out of your pocket as an investment. And after 6 years, nothing happens here, but by the sixth year, you get a payoff, right, of 2,000. So we asked this question, what interest rate would you need so the net present value of this investment is zero? Okay. So basically, we take the net present value equation we previously knew and we set that equal to zero, and we simply solve for the internal rate of return here. Okay. Again, this is the net present value equation, but now we're going to try to find the spot where the net present value is equal to zero. This is, I guess, like the break-even point, right? So we rearrange the terms, and eventually we take r is equal to, and we take this to the 1/6 power, right? And we come up with 1 plus r is 1.1225, or r itself is 12.25%. So this rate is the internal rate of return of this investment opportunity. Making this investment is like earning 12.25% per year on your money for 6 years. So let me highlight that because that's an important concept, right? Let me just highlight that. So this 12.25% is like earning that amount per year on your money for 6 years. So if you invested 1,000 and you earn 12.25% every year for 6 years, you would have $2,000, right? So basically, as they say here, when there are just two cash flows, it's easy to compute the internal rate of return. Now let's look at the general case in which you invest a certain amount today and you receive the future value in n years. Then the internal rate of return satisfies this equation, right? So basically, this is the present value. Here's the future value. And here's the internal rate of return, and here's the number of years. So let's set this highlighted. So the internal rate of return with two cash flows is the future value and the present value, which is what we just saw, 1 over n to n minus 1, and that's, here it is right here, right? So here it is. So this is the general equation of what you see up there. And this is equation, hello, 4.15. So we take the total or return of the investment over n years, which is f of v over p, and convert it to an equivalent 1-year return by raising it to the power of 1 over n. Because we are just comparing the two cash flows, the calculation is equivalent to computing the compound annual growth rate, which we will learn more about later. And this is the geometric, the definition of the compound annual growth rate is the geometric average annual growth rate, year-over-year growth rate, which, if applied to the initial value and compounded, will lead to the final value. So this is the compound annual growth rate, right? And basically, another use for the internal rate of return is for a perpetuity. And a perpetuity is something that pays a cash flow forever, right? Perpetual, perpetuity, perpetual. And we'll look at that in this example here. So I guess Jessica graduates with her MBA like you will, and rather than take the jobs, she's decided to go into business for herself. She believes that her business will require an initial investment of $1 million, which you can see that's reflected here, right? Right, you see that? After that, it will generate a cash flow of $100,000 at the end of 1 year, and this amount will grow by 4% per year thereafter. So it's $100,000 the first year, and then each year it grows by 4%. What is the internal rate of return of this investment? So this is the growth rate, right? 4%. So the timeline here shows the cash flows. The future cash flows are a growing perpetuity with the growth rate of 4%. So this grows at a 4% rate. So recall if you look at equation 4.11, if you go back from equation 4.1, the present value of a growing perpetuity is simply that equation right there. So basically, the net present value of this investment would equal 0 if and only if 1 million, right, is equal to, this is your initial investment, is equal to this, right? So we have a growing perpetuity, and we move this over because it was equal to 0, so we move this over to the right, right? And if we solve that equation, the internal rate of return on this investment comes out to be, you can see, 14%. All right. So just by the act of growing by 4% each year, the internal rate of return is 14, and this is for a growing perpetuity. Okay. So if I generalize it, the internal rate of return, and this is an important equation to know, and I'll highlight that in blue, right? Of a growing perpetuity is the cash flows, which was up here, right? See the cash flows over the present value that you shelled out, $1 million, plus the growth rate, right? And you can see that. That's how it was solved here, right? All right. So let's now consider a more sophisticated example. Suppose your firm needs to purchase a new forklift, and you have two options: a price for the forklift if you pay cash, right? And the second one is the annual payments if you take out a loan from the dealer. So we want to evaluate the loan and see which one is basically cheaper, right? So you want to compare the rate of the loan with the rate that the bank is willing to offer you. So basically, you could either pay cash, right? Go to the bank and get a cash loan, or take payments with the dealer. And people do this with their cars, right? So the question is, how do you compute the interest rate charged by the dealer? So we need to compute the internal rate of return of the dealer's loan. And suppose the forklift was 40,000, right? And the dealer offers financing with no down payment and 4 annual payments of $15,000. All right. So this would be the cash price of the forklift, right? But he's going to let you pay it off in 4 installments of $15,000. So you can see the signs are a little different here, because the money's coming out of your pocket each year, right? All right. So from the timeline, right, it's clear that the loan is a 4-year annuity. This is an annuity, which means the constant payments and constant time intervals of 1 year, right? And here's the present value of 40,000. So we set the net present value of the cash flows equal to 0, right? This was the initial investment, and it requires that the present value of the payments equals the purchase price. So we get the present value of the payments here, right? Which is right here. And again, this is the net present value equation in disguise. And of course, we're going to solve for R. And it's basically, you would use Microsoft Excel to solve this, because as you can see what they say here, there really is no simple way to solve for the interest rate. What we're going to learn in chapter, I believe, 7 is there's a lot of pitfalls to the internal rate of return. So we'll spend a lot of time on that, right? So they start guessing here, but you don't have to guess, because we're going to use Microsoft Excel, right? And they keep guessing and guessing and guessing. And the interest rate charged by the dealer is 18.45%. And that's the correct rate, as you can see here. Okay? All right. And now an easier way to solve this is to use Microsoft Excel and try to and use the rate function. We're looking for the rate. So what do we know? We know the number of periods is 4. We just plug that in, and we know that our payments are $15,000 a year, and the present value is $40,000. The future value is 0, and Microsoft Excel will pop this out with no equations, and it'll compute the internal rate of return. There's another way to do that too with cash flows, okay? And I will get into that later. I'll get into that later, okay, when we pick up at this example here. What I want to do is cut this off for now, and I'll make part 2 later.